All right, we're going to do a little bit of an integration review. We have been doing some integrations, looking for our volumes in the discs and the washers and those types of things. So again, just some strategies for integration before we continue on to our next unit because it is full of integrations. Some techniques that will help you integrate is multiplying by a form of 1. This is to help you get the factors where you want them to be, say for U substitution, something like that. Doing some simple algebra like foiling and factoring, that will help with integration. Write two fractions. You can always separate the numerator over the denominator, but never separate your denominator. As I said, U substitution. There are some trig identities we can look at. We'll complete the square part of these trig identities I want to show you. Use long division for when you have an improper rational expression. That means the top is bigger than the bottom. And look for a natural log pattern. That's when you're trying to integrate x to the negative 1 power, or 1 over x. So as I mentioned, and this is a PDF file that you can print out. All right, so the first page, there's all your derivative rules that you might want to review for when you do U substitution, especially with your trigs. And here's some of our basic integration forms that we look for. There's our power rule. Here's the natural log rule. Integrating e to the u is e to the u. Integrating some base to a power is that base to a power divided by the natural log of the base. Here's your trigs. We got all kinds of them here. Here's some of our trig identities that I was talking about. A lot of perfect squares on the bottom. When you see square roots of difference of perfect squares, or in the bottom sums of perfect squares, there's some of these inverse trig functions that we want to use. So just keep this in mind, have it handy. Again, I will provide this for you at the test, but I would always have this handy taped up somewhere when you're doing your work. So I'll refer to this as we look at some of the review problems that we're going to do here. Okay, so example number 1. I see this as a fraction. As I mentioned earlier, I'm thinking 1 over x. Some kind of fraction with x is in the denominator. Think ln. All right? So I want to try to rewrite the denominator as just one variable, but I have variables on the top. So here's what I'm thinking. If you look really close at the terms, think of U substitution. If I have to take the derivative of x squared, it's 2x. If I take the derivative of x, it's 1. This is a perfect setup for a U substitution. Let the denominator be u. Then take the derivative of the denominator. You get the 2x plus 1 on the top being multiplied to dx. A straight substitution to integrate 1 over u du. That will be the natural log of u, or I should say the absolute value of u, plus c. Then you take your u, which was our trinomial, plug it back in, and we're done. Now in example 2, we really don't have that situation here. One of the dead giveaways for a U substitution is look to the x with the biggest power and see if there's another expression with x to the next smallest power, so squared to the first. Then you can do a U sub. Here, they're both to the first power. But I noticed that x minus 8 is always going to be smaller than 4x. So what we have to do here, this is an improper fraction, so we're going to divide it. So I'm going to divide x minus 8 into 4x, so x goes into 4x 4 times. That gives me 4x minus 32. I'm going to subtract everything, so think of this as 0 minus a negative, which is a plus 32, and I can rewrite this fraction as 4 plus 32 over x minus 8. So now we replace that in our integral, and then we can separate it as to 2 separate integrals. Well, we can integrate 4, that's just going to be 4x. Factor out the 32 from the numerator, 1 over x minus 8. Now it's back to our natural log. So the derivative of x is just 1. We don't have to do a u sub. This would be the natural log of x minus 8 in your absolute value bars being multiplied by 32. Integrate the 4 to 4x and make sure you always add that constant. Next, example 3. This one's a little bit more difficult to see. Whoops, come back here. I do have e to the x in my denominator, so I'm trying to think u substitution, but the derivative of e to the x is another e to the x, and I don't have that anywhere. I can't just magically have it appear. So here's where, if I want to do a u sub, I need another e to the x in the problem, especially up here in the numerator. So I'm going to multiply this by a value of 1, but make sure it's got some form of e to the x in it. So my fraction is going to be e, let's see, e to the x times e to the x. That would be e to the 2x. Okay, I don't want that. That's not going to give me what I want up here. So I'm going to multiply by e to the negative x over e to the negative x. Reason being, when I distribute this to this term here, when you multiply like bases, you add the powers, which will make it a 0. That will cancel this out, but I'll have an e to the negative x on the top and an e to the negative x multiplied but to that 2. That's all I need. Also notice I took the 5 in the numerator and factored it out to the front. So there it's distributed. Now I can do a u sub. U is going to be 3 minus 2 e to the negative x. Take the derivative of this. That will be e to the negative x, but it's a chain rule. Then you got to take the derivative of negative x, which is negative 1. So that's going to change my minus 2 to a positive 2 e to the negative x dx. I don't have a 2 in the numerator. That's okay. We'll just divide it over to the 2u. So there's my e to the negative x dx. And now we'll do a u sub. There's my 1 over u. Du over 2. Just take this 2 and factor it out to the front. We'll call it 5 over 2, integrated 1 over u du. That will be natural log of the absolute value of u. With the 5 has multiplied it to it again. Never forget your plus c. Switch your u back in, 3 minus 2e to the negative x, and there's our answer.